Hey, good morning, everyone. Welcome to Whitmix's webinar, Sinter, Glaze, and Go. Not just possible, imperative. This is part one of a two-part series. My name is Bernie Jaroslow. I'm the marketing manager for Whitmix, and I will be facilitating today. So before we begin, I just want to talk about a couple housekeeping items. The first, in the, I believe, upper right-hand corner of your screen, you probably have a questions box. Feel free to use that. Type in any questions you need. We won't be able to hear you, but if you type in the questions, I can see them, and then our presenter, Al, will be answering them at the end of the webinar. So feel free to type in as you go. Next, if you are a CDT, this webinar is approved for an hour toward your CE credit. So you'll receive an email within 1 to 2 days. It'll tell you exactly how to obtain it. It requires doing a very simple test. Just pay attention, but it's an important test, and that will get you a certificate, and you'll be able to get your CDT credit. Lastly, the webinar is being recorded. That too takes about a day or two before it's up on the Whitmix website, but you're always able to get the webinar, rewatch it, have other people in the lab watch it, and also to get CE credit for CDTs and RGs. So just give it about 24 to 48 hours and we'll have it up there. So this morning, I'd like to introduce Al Fillastre, CDT. Al began his training in dental technology shortly after receiving his BS degree in chemistry from Stetson University in 1975. He worked in a variety of commercial labs and then returned to Lakeland, Florida in 1979, where he began working in his own lab alongside his father, Dr. Alvin J. Fillastre. Since that time, Al's been an accomplished technician in all disciplines within the Crown and Bridge lab. He's extensively published, presented numerous hands-on clinics, webinars in occlusion, ceramics, composite resins, waxing and metal design, and many, many others. Al has lectured extensively to technicians and dentists alike on quality, excellence, communication, and technical skills. Al's also been recently been involved with the development of the Danar 300 series articulator, and at this time he owns and operates Ceramo Arts Dental Laboratory in Lakeland, Florida. Today, in part one of the series, Al will present a comprehensive approach to creating functional zirconia restorations. There's much more to zirconia restorations than just milling and coloring. So the first part of this series will incorporate the concepts of function and occlusion into your designs in order to consistently produce successful and functional zirconia restorations without grinding and compromising their strength and efficacy. Full arch versus quads and full frame versus plastic articulators will also be covered, along with the proper use of 3Shape's Virtual Articulator. So there's a lot to cover. That's all I've got. So Al, if you're ready, let's talk about creating functional zirconia restorations. Al Fillastre.
Well, thank you, Bernie. Well, that pretty well covered it. So I guess we're about done, right? Just joking. But anyway, yeah, you know, this came together because, you know, in some programs I've done, really talking about, you know, producing zirconia restorations, coloring different approaches to that. I always pointed out that it's a very tricky material, and once you start grinding on it, it's a problem. Well, then how do you avoid doing that? Not only to make a better restoration, but to, you know, improve speed through the lab, and you know, everybody's under pressure these days. So that was the motivation behind trying to put this together. Whoops, what happened? Guys, I lost my program. Let me see. There we go. So in starting, just a quick rundown of basic zirconias. Everybody's familiar with these. Everybody's got them. Every company. These happen to be Whitmix's brands. HT is the old, you know, 1255 megapascal, the old standby. HTX is their version of the anterior zirconias that came out like 5 years ago, a much lower strength. Personally, it never had much place for those in my lab. since it really wasn't significantly stronger than Emax. And then the new class of zirconias, which now most companies are coming out with, calling them different things. Wimix calls them Pro. Basically, they're a blend of the first two. A little more complex than that, but that's pretty close. And they also show great strength and great translucency. And for my lab now, this is pretty much the only type product that we use. Of course, anything we're talking about here can apply to anybody's zirconia within these classes. And trust me, there's very little difference from class to class, company to company, as far as that goes. But one thing that's really important to understand is that, you know, all companies prepare these perfect samples. When you see these numbers here, you know, advertised by companies referencing their zirconias, you take that with a real grain of salt, because these samples they produce, they spend big bucks on getting these produced and sending them to the companies that test it so they can get the maximum possible numbers out of it. No scratches, no blemishes, perfectly polished, perfectly square. Which we really can't do, and it doesn't really represent what we produce in our laboratories, which are crowns and bridges with connectors. And so typically these numbers are the best number they got out of all their samples, generally 10 that they'll run. And I do know with Whitmix, though, the numbers that they report are the lowest number they got. So again, though, these numbers really are meaningless except for just a base reference, product to product. But because of zirconia's unique properties, and it does behave like a ceramic, even though it's not, you really need to be careful that you don't damage them after sintering them, and it's really hard to quantify exactly the kind of damage that can be done. There are a number of studies out there. Okay. Oh, I'm sorry. I got out of whack here a little bit, but really to accomplish this, you need to adjust the occlusion during design and finish them completely in the green state to avoid, again, grinding on the post-center zirconia. So, you know, I went looking around, and if you look, there's a ton of studies out there that test all kinds of different things. But the bottom line that I found was that when zirconia is ground on, it can have a significant strength drop. And if you look at these numbers, they're not anywhere near the numbers that companies will produce. Nearly 1,000 megapascals is adequate, but it ain't 1,200 megapascals. And also, this particular study determined that any kind of damage from grinding could have an impact on long-term fatigue behavior of lithium stabilized zirconia. And again, you know, you can knock yourself out reading a bunch of studies. The fact is that this is something we should all be concerned with. But to do this hinges, number one, on proper design, and then proper use of virtual articulation to adjust the occlusion properly, and of course, green state finishing, which we'll get to the next time. So, but all of this hinges on proper understanding of function, morphology, and occlusion. And because they're not designed right, if they don't function right, you're going to be grinding on them at the bench. And so I wanted to pause this a little bit, go back and review kind of the basics of what's going on with occlusion and function, and bring everybody up to speed so we're all on the same page, you know, understand as we go through this. When you look at occlusion, there are two distinct and separate components that work together. There's a posterior component to occlusion, which is the mandibular condyles riding along the temporal eminence of the skull, okay, up in the glenoid fossa. Then there's the anterior component, which consists really of the anterior teeth and what we call cuspid guidance or anterior guidance. And so these two things are completely separate, yet they function together to provide all the movements that we deal with occlusion. So there's two components, the skull and the mandible, and we'll just take a quick look at the skull and see what we got. Of course, the anterior component is the anterior teeth on the maxilla, and the posterior component is housed within the temporal bone, right in there. And I think everybody knows this. We've got the glenoid fossa where the condyle sits. We've got the eminence, which is the condylar guidance angle, provides that. We have the articular tuberosity, which stops the forward movement of the mandible, hopefully. And then, of course, this angle represents the condylar guidance angle. Interestingly, in humans, it's typically between 40 and 60 degrees, actually more often closer to 60. Yet, when we reproduce this architecture in an articulator, we always set this guidance to somewhere between 20 and 30, which is kind of interesting, and there is a good reason for that, and we will talk about this a little bit later, exactly why, and most of you probably know this. And again, if we look at the bottom of the skull, the way it's designed is just like the way an articulator is designed, and the condyles fit in there. And that really represents the part of the mandible that we're concerned with, along with the anterior component, which is the teeth, and providing anterior guidance along the linguals of the upper teeth. So when we look at our articulator, we can see really the bottom bow is a big mandible, okay, and it has 2 condyles, and the upper bow is a little skull, but basically represents this. Okay, so that at least we have some geometry that is similar to, not exactly like, but similar to the skull, because there's a lot of variables that we just don't address, okay, in our day-to-day work. But when we look at how teeth are arranged, and this is really important to understand this stuff, that ideally we have a horizontal plane of the teeth that's parallel to the interocular line, which defines the horizontal axis of the skull. We all know that. We use the pupils, but we assume that the eyeballs are equally centered in the sockets, which is an assumption you really can't make. But, you really have to go with things that are averages and common. It does work out very well. And of course, when the Frankfurt plane is drawn from the ear canal to the tip of the nose, the perpendicular to that is what's defined as the vertical axis. And then the teeth sit at about 10 degrees down tilt from that axis and about 110 millimeters average from the condyle. Okay, which interestingly is the average same width that the mandible is, condyle to condyle. Interesting. There's symmetry there. And of course, then the mandible is in place and it's equally position between the Frankfurt plane and the tip of the chin. And all these averages come from a man called Bonwell, who was kind enough to measure thousands of skulls and give us these. But when we start looking at the movements that go on with the mandible against the skull, I'm just going to take a sort of generic mandible here and go through this, because there's just a couple simple concepts that if you're not familiar with, you need to be, and we don't talk about this very often. So that condyle is this condyle. This just represents the side view, so that those condylar heads and those balls right there are the same thing, just 2 different views, one from below and one from the side. So we can watch what they do as we go through movements, okay? And then we have a particular condylar guidance angle set, whatever it might be. Okay, typically 20 to 30 degrees. So if we go into a right lateral movement, a couple things are noticed. Number one, the working condyle, the side to which the mandible has moved, doesn't go anywhere. It just rotates. All right. Whereas the non-working condyle, and this is kind of an oxymoron, is actually the one that translates or moves down the eminence, but it also, because of the condylar guidance angle, moves down physically. Okay, so it actually moves the mandible away from the maxilla, and the amount that it moves down is dependent upon how steep this guidance angle is. If this was shallow or 0, it wouldn't move down at all as it moved along. So that's a critical thing to consider. And of course, everything rotates back and translates back when we go back to centric. And a left lateral movement is exactly the same thing, right? The working condyle rotates, doesn't move. The non-working condyle translates forward and down, okay? Again, the amount dependent upon the condylar guidance angle. Now we go pertussive movement. Both condyles move forward at the same time, forward and down at the same time. But also there's a third component that comes into play because of the angle, medial angle of the medial wall of the fossa, the glenoid fossa, is that it now, as the mandible translates down the eminence and forward, you create the ability to have side-to-side movement. And in reality, this side-to-side movement can also occur in centric. This is not necessarily locked in. We call that immediate side shift. But for our purposes, it's not. I want to keep this simple, okay, as simple as I can. Sorry, my phone rang. It was supposed to be on mute. Anyway, so if we look at all the possible positions of the condyles, they form what we have always called the envelope of function. But if you look at it, it's actually triangular in shape. So a condyle can be anywhere in this space. The 2 condyles can. during function. So if we get back to the teeth and look at why this stuff is important, number one, I'm a believer in anterior guidance, and I think a lot of people are. And basically, in this system, the anterior guidance separates the posterior teeth when moving out of centric, and the posterior determinant of occlusion, which is the condylar guidance, determines how much they separate. Okay, so these two things work together, anterior guidance versus condylar guidance angle, to determine where the teeth are in space as they move relative to each other. And this system is designed so the delicate front teeth, delicate biters, actually are the ones that move the powerful posterior teeth or chewers out of the way, so they don't destroy themselves, okay, through the nutcracker effect, because you can develop a lot of force back here. It's kind of interesting, though, that you can't develop much force against these teeth. If you ever try putting your incisors end to end, slide your mandible out and slide your lowers to your incised ledge of the upper, you won't be able to press very hard. Okay, your masseters are cut off when you do that. It's really a brilliant system. And if we look, the posterior teeth separate as soon as the mandible moves. If this fails to happen, we create interferences, and we're all familiar with interferences. But what's really important to get out of all this is that the condylar guidance separates posterior teeth quicker in protrusion and on the balancing side, but not on the working side, okay? Because the working condyle doesn't move. Remember, it stays put. So there's no drop, there's no separation, nothing goes on with this condyle on the working side. So when we're first looking at a case, and that we're going to be doing, that's one reason why a study model is such a great idea. When we put this into function, we notice nothing's touching. Okay, as we go into a right lateral movement, none of these teeth are touching. So what's causing this? And if you look, there's not even any cuspid guidance. What we have is a huge balancing interference back in the posterior on the left side. Big balancing interference, okay? And, if you think this could actually be in the patients, they actually function this way, they don't. Trust me. This kind of an interference makes people crazy, and they cannot tolerate that. A working interference, different thing. We also call that group function. But if we take this case and just simply move the guidance angle from 20 to move it all the way up to 60 just to see, and then go back into a lateral movement, we see we have exactly what we want. Posterior exclusion, cuspid guidance, even a little bit of group function up in here, but nothing touching back in here. And this simply is accomplished by increasing condylar guidance on the non-working side. But we always do it symmetrically and unilaterally, okay, because we also want it to affect protrusion when both condyles do translate forward and down. But did we really need 60 degrees in this case? No. I mean, when you're really doing this, you want to move it just enough to separate these teeth and no more. Okay. Now, if we start looking at function, there's two main concepts when we call it just about hinging, with the way the system is set up. And if we look at arc of closure, that's simply just looking at where the condyle on the machine is versus where the maxilla is and the arc that this makes. And on an articulator, this is pretty similar to what the human mandible does when it swings down. If we look at what most of us use these days, these plastic articulators, you look where this condyle is relative to the teeth. The arc is much smaller, and it's at a different angle. And the old metal articulators, which are not much use these days, matter of fact, I don't think anybody's using them. It's kind of somewhere in between. But if we look at the three of these and we look at the arcs, the actual arc moves forward as the hinge moves down. As we go from an articulator to a hinge to plastic, and I'm going to call plastic like Vertex or Orbix or those articulators, those types. Okay. And what's more interesting when we look at this is that it's quite a big difference. Okay, on an articulator, the mandible actually moves backwards slightly. On a hinge, it moves a little more vertically. And on our plastic articulators, it drops almost straight vertical. Nothing like what happens in the real mouth. Now, you look at this and you go, yeah, so what? And most times it really is a so what. But there are times when this is really important to understand. Okay, so I just want to show you a little exercise that I did here, where I just built up some teeth, like with a big pad here. Of just some Emacs that I pressed just to look and see. And I made this arrangement where I have a mounted case that's also got the little plastic articulator. So I can look, I can unclip these and look at the movements of that, or clip those and look at those movements in order to get some of this. And what we saw was that on the articulator, we got centric back here. But on the plastic, the Sinter goes there. That's a big anterior posterior shift with about 3 millimeters of vertical opening, which in some situations we do all the time. Okay, remember the arc moves forward as the hinge moves downward. Okay, and that's the implication of that. So, you know, that's one compelling argument for taking face bows and using semi-adjustable articulators, right? Particularly if you know you're going to be opening vertical. But the truth is, I don't use face bows. I don't really like them. I prefer a mounting platform, which puts the maxillary cast in the average Bonwell position that we discussed earlier. But that's really beyond this program. But for things like dentures, and particularly today for splints, this is really important, because if you have that kind of anterior-posterior change and you start adjusting a splint on a non-physiologic articulator, you can really screw things up. But all this being said, this probably concerns me the most, okay? And so I just took an articulator, I measured the condyle, I measured where the cuspid, I put a marker where the cuspid was, did the same with a little plastic articulator, right? And there's the cuspid, and then just drew the arcs to see what's going on. So when your mandible moves sideways, it's hugely different what goes on, okay? When you look at plastic, it actually moves backwards as it goes sideways, whereas on the articulator, it moves almost straight laterally. And so if we extend those lines and put that back here, what does that mean? It means, holy mackerel, a cusp here will actually travel between these two buccal cusps, but there it's going to interfere. But this is what we'll see if we're on a plastic articulator. Okay, completely non-physiologic, and you can already imagine this can create some huge problems. And here's just a sample case we look at. Here it is on the articulator. There it is on plastic with a right lateral movement, okay? And just look at this. Look where the distal, the upper cuspid is relative to the lower. On articulator, it's almost even. Look at plastic. It's the mandible went backwards really fast, okay? Completely different position. If we look at this, we have a little interference here on the articulator, which is physiologic, okay, more of a sideways movement, but look at this. Look at that space. Now, if you saw that and you saw this reverse curve, your inclination would be to lengthen that cusp, right, to fix that. But if you did, what do you think would happen in the mouth? Okay, it could be a real problem. Okay, and this one thing right here accounts for probably 95, if not more, % of the adjusting that doctors do to our beautiful crowns. So, you know, I mean, people say, yeah, these are fine on single crowns, and they are, because we rely on all the tooth guidances. We have no functional guidance. So, you know, because that's certainly not physiologic, you know, but I would say, yeah, fine, well, let's say that it's safe on single crowns, because, you know, it can cause things that we may not even be aware that we're doing to our crowns, you know, and I'm going to run through a quick idea here of this, but here's a case at a 25-degree guidance in a lateral movement. We had some balancing interferences here on these inclines, which we're balancing. So at 60, though, we eliminated this one, but not that one. So what that means is that the patient either has this small balancing interference, or they have an even steeper than 60 guidance, which we never do. So my guess is they actually have this little balancing interference. But now let's take everything away, okay, and turn this into a quadrant. And we're going to remove the no anterior component of occlusion, especially on the working side, okay, the side to which the mandible moves, which usually comes from the cuspid. We have no posterior disclusion because we have none of this going on over there, okay? So when the mandible moves that way, it's only the teeth that guide it. This is what we see on quadrants. And so this angle is what's guiding the movement, okay? So this becomes an excluding angle for all of our teeth. Okay, the real situation is this ain't there. Okay, a little something there, but nothing like this. So we look at our marks on the articulator, on the plastic, and we see this huge interference. We grind this away. And the truth is, though, you know, now, is that safe? Yeah. I mean, if we do it, fine. We take away some anatomy, but the truth is that interference isn't even really there. This one is far from being there. Remember this balancing interference we saw on this first buy? It's not even close. But this one does appear to be there. You can see it. Okay, so this little one is there. This one, though, is not even close in real life. So it's a huge problem when we look at virtual articulation on plastic, because in the software, we're always using a full frame. Okay, this is why, exactly why your techs grind on crowns that you spend all your time designing and running through the virtual articulator, but they're all one of these, and they're picking up on all this stuff because the teeth don't move right. Okay, and it's something we've come to accept, but in the world of digital, it's huge. It's a huge problem. So when I started wanting to understand virtual articulation, I watched every YouTube video there was. 3Shape's got nothing. I read their manual. There was nothing out there that teaches you how to use this thing or what anything does. And I talked to my reseller, and they're like, yeah, well, there's your contract guidance and a couple things, but it actually goes much deeper. And virtual articulation actually does work quite well. This one, though, this optimized occlusion, yeah, I don't use it, okay? But, well, once in a while. But this, it suffices to say be extremely careful of this, and we'll talk more about it in a bit, okay? This icon saves your current placement to a file. Well, you'll see why that's important later. This performs an auto placement of your cast based on something you saved when you moved a position. This obviously just uses the articulator, okay? But then when we go in to this, we have some icons here we can check. This, where we either allow or disallow a movement, does not allow or disallow it in the articulator function. Only disallows it when we drag the models by hand by clicking on one and moving it around to see a movement, and that doesn't work very well in 3Shape anyway. Okay, and then this is the wrong place. This auto shut mode right here. Okay, you can set it to the first point of contact, or you can set it to a thing that prevents jaws from penetrating, or you can turn it off. And I have yet to see anything useful besides setting it to the first point of contact, which means when we push this button and take it back to centric, their jaws will come together, and as soon as something touches, they'll stop. And if the occlusion is balanced, which it should be, that's exactly where you want to be. It takes you back to centric. So you always want this one clicked, okay? This, I don't even know why they had it, okay, why they have a button for this, because with standard coloring, you don't see anything. I mean, I don't know what's going on here. As soon as you click that button, suddenly it all comes alive. Now we know what's going on. We know where our balancing interferences, our working interferences, our long centric, we know where everything is, and our protrusive interferences. And I don't know how many of you are really familiar with the legend of the key for this thing, but we'll go over it real quick. Again, we have these three here, and what I want to say to this is that pretty much the first two need to always be clicked. To record the contacts, that's kind of a no-brainer. To collide inside a plate, which means the teeth guide off each other. Teeth can't penetrate each other. You have to have that. And then collide designs, that means to allow the angles on your crowns to actually influence the guidance. That's supposedly checked for anterior guidance only. Well, supposedly, but not really true. Okay, we'll talk more about this later too. There's a little bug associated with that. But the primary thing going on is that it's never right. On this particular articulator, this is where your maxilla ends up, which is not the way it's supposed to be if you remember all this, all right? So where it's supposed to be is centered. So this is 110 millimeters. That's 55. That's centered vertically. Okay, so it's 12 millimeters off. And if you remember from Bronwell, it's supposed to be about in this position, 10-degree down tilt, 110 millimeters from the condyles. That's nowhere close. All right, so first thing you have to do is just make sure you get your maxilla in the right place. So I just started looking around, measuring things, and realized, okay, we need to move this about 20 millimeters forward. We need to raise it up about 12. So when I line up my teeth, I just run it a little bit forward. Now, I'm going to get specific here, but it's not that critical. But you might want to check this one time and kind of see about where this position is in the particular articulator that you use. Understand they're all cartoons, and they really just, they all function exactly the same. It makes no difference in the function based on which one you select. It's just whatever picture you like. But again, I just put it where I was about 110 millimeters from the condyles. I actually did some testing to see how do you get 10 degrees on this. And what I found out was when you put this 1 millimeter grid and put your central here, you count in 8 blocks. That line should go through that corner, that first corner up. If you want to do it, you can do it. It's a way to kind of quickly get 10 degrees. But you can just kind of guess. It really works. So once we have it in the right place, we make sure that we're centered left to right. which you get when you have the thing, and then you can save this. Okay, give it a name, proper 320 placement, and now you can play that with this icon after you scan occlusion to get it in the right place. But I'll warn you, it doesn't always work. Again, every other articulator in the system has its own little quirks about where they put the cast. Just be aware of this stuff and find out where that proper place is in your articulator, and then mark it, save it, and then go from there. Now, is there any other way to get the cast into the articulator properly? Well, 3Shape does have these things. You guys may have tried these, may have not. I went through a lot of pain trying to get this to work, and I'm not a fan, got to tell you. And number one, I've tried every kind of mounting stone, die stone, you name it. Nothing I've tried is stable for a month. This was like zero dimensional change mounting stone. It has dimensional change. Okay, after a month, I saw this much opening. So, you know, that's not really the problem. The problem is that within 3Shape, this doesn't really work because it depends on the optimized algorithm, which I think has some errors in it. And I don't like it. Okay, but if you do and you like this, knock yourself out. But this little guy, you know, which is the $100, you know, iPad cover, is really does work good though for finally being able to get an articulator into a 3Shape scanner if you have an open scanner like the E series. Okay, and it does capture occlusion as good as 3Shape can capture occlusion, which isn't perfect by any means. So I want to talk a little bit about, you know, utilize the virtual articulator once we correct the position of the models. But remember, there's a big difference between when we have articulator mounted models, full arch, and hinge quadrant models. But in every case, the first thing you want to do is flip the models over after you place your tooth and look at this. Okay, this seems to be a universal problem. I think worse in the trios, where after you capture occlusion, they penetrate, and they almost always do. It looks something like this typically. So after I place my tooth, the first thing I do is go up here. I activate the articulator, go to this icon right here, right, and then look, and just increase vertical straight up. You know, like I said, I don't like the way this works. I don't like what it does to the jaws. But I found that if I just go up, usually about 100 microns, that's a lot, 50 to 100 microns, in order to get this to actually, for these little penetrations to disappear. Now, you know, you can do what you want with this, but for me, this is working fantastic. Then don't forget to save, because it'll go back when you leave. And again, once we started doing this, we were having to set occlusal contacts to cut to usually a little bit positive or a little bit negative, or, you know, all over the place to try to figure it out. Once I started doing that at the end and I cut to 0, I get really exactly what I saw on the screen when we look at the crowns and look at the milled wax or the pressed crowns or the zirconia or whatever. And again, I cut them to 0. This is to show you, you know, contacts, we're finding the exact same contacts. And it's pretty cool, okay? Now, as far as the occlusal compass goes, this is, it's in the manual, okay, from 3Shape, but pretty much, okay, centric is red, working interferences are blue. Okay, that's a working movement. Group function, not really destructive. They also call it lateral intrusion and lateral protrusion, which is yellow. I've yet to really see yellow. You know, I really don't see that much. So blue is basically a working interference. They call it lateral intrusion. Green is a balancing interference. These are the bad boys. Okay, these are protrusive interferences are bad boys, the ones you really want to get rid of. Patient can live with this as long as it's group. So they call it media intrusion and medio protrusion, orange. I never see that one. Okay, so lateral intrusion, media intrusion, working balancing, and then they call this red immediate side shift, which retrotrusion, retrusion, and I don't really get how they determine that. It's more like a broad centric. It's kind of like the area around centric that you get if you put your tape in and kind of just make little circles with your teeth, barely moving them. You'll get this kind of enhanced area of centric, and I call that broad centric. I pay 0 attention to this, by the way. So pretty much in their thing, anything above the line is okay. Anything below the line, mainly green, and protrusion is not okay. Okay, but is that important? Okay, I see an existing balancing interference on this cast when I go into the articulator. So the answer is yeah, It's really important. So now remember, only on full arch models that are actually mounted on the articulator. You have to go in and eliminate this on your existing teeth before you start adjusting your occlusion, or this is most likely not there in the mouth. Patients don't like these things. And so how do you do that? You increase contour guidance, right? You go back here to the screen. That's 20-degree guidance there. If we bump it up, okay, in this case 45, I usually go in increments of about 15 degrees, boom, it's gone. So we want, would be the appropriate contour guidance for this patient. We noticed that we still have this one over here, right? So I went back and went to 60, and it was still there. So what that tells me is this patient has this little bouncing interference. And if you want to be a hero, tell your doc. Say, hey, doc, are you aware your patient has a little bouncing interference on the lingual cusp of that bicuspid? Now, after I place my tooth and get it about in position, and I've adjusted my penetration, I'm ready to cut this back to my first, to start really doing my occlusal, I cut them back to negative 0.01, 10 microns. Why would that be? So that I can see them, right? I mean, you've got to be able to see them to be able to manipulate them. If you cut them to 0, you're not going to see them. If you make them any heavier than 10 microns, they'll interfere with your movements. And so you'll see interferences that aren't there. So I found that that's the perfect number to set your occlusal contacts cut to be designing occlusion. And again, we check all these boxes. By design must be checked, by the way, because if you don't, you're not going to see all the markings that are on the tooth, okay? It doesn't translate to your crown. That's a little bug in 3 shape, all right? So even though this is intended to be really for anterior guidance, you need all 3 checked all the time, anytime you're using this, to make a long story short. So you can see what's going on, okay? So we cut our contacts to negative 0.010, 10 microns. And then start to basically just eliminate interferences that we don't want. So the first are the green, the balancing. So green is not good, green is bad. So I go through and I do this by hand, okay, with my sculpting tools. I do not like optimize, and I don't like to adapt designs either, because it takes away too much and it's out of my control. It takes away centric as well. And I really don't like the way that it functions. It's easy enough to go in on my own and just remove what I don't like. Okay, so I check out my centric, I go through a movement, and I've gotten rid of the interferences that I don't want, mainly green and gray. Okay, blue is important to get rid of too. Okay, and then I used to, like I said, I used to have to cut my occlusion to 20 microns shy to get, not to have it so heavy after it comes out of the mill or comes out of the press. But since I discovered that penetrating occlusion thing that I just showed you guys, I found that when I cut it to 0 at the end, and just after I'm finished adjusting, I see where my contacts are there, cut them to 0, and I get great. I get exactly that back out when we get to the bench with the crowns. Now, for anterior guidance, I'm gonna zip through this. This is just a basic anterior guidance case. Just show you some of the things to look at. We have existing balancing interferences, right? And so we see that's one thing that's wrong here. And we also have some working interferences, which is there's a lot of group function going on here and back here. And typically you don't really see that, okay? Typically that's an indication that the cuspid guidance is a little bit too shallow to lift this off as the mandible moves that way. Now cuspid guidance does affect the amount of lift off the anterior component when we go into lateral movements. And those existing balancing interferences, I definitely want to raise the contour guidance to eliminate those. So once we get that done, we can start looking one side at a time. Now, I do see that we have some working interferences, some group function here, and I would like to eliminate that. All right, so I'm just going to increase the path along which the guidance takes place, then cut my occlusion back to 0.01 and check it again. Okay, run it through, and sure enough, they're gone. Now, did I put too much? So what I'll do typically is take away a little bit and see what's up, and see if I can just run over it one time, take away a little bit, because you want the guidance only as steep as it needs to be to eliminate any posterior working interferences. And it came back, so I just go back, undo that, right, and then I'm back where I started, and that's good. That's the minimum angle on the cuspid that'll get rid of any of this stuff, right? So We go look at the other side now. And when I look at this closely and just run through the guidance, I've got nothing on this tooth. I've got no working interference. So maybe I can lower this a little bit, right? So I'm going to take away a little something and run back through it again, and then boom. Okay, now I got that. So I'm just going to go, in this case, I'm going to go back and just undo it. That's the easiest way to get back where I was. And then I'm going to have that little bit of exclusion back again. So once I've got the cuspids protecting the posterior teeth, now I want to look at protrusion. And again, typically we want to always limit that to marginal ridges. But I'm not a fan of having much, if any, contact on the cuspids. I mean, pardon me, on the laterals. I try to have it all taken by the central mostly, and by the distolingual incline back on the cuspids. So when I see this huge protrusive interference on this lateral marginal ridge, it concerns me. I'll try to take it away a little bit and see what happens. And I now get a little bit of taken over on the centrals, but I still got a little bit here. And, you know, and I now have developed this. When you see this, you're going to chip that incisal edge guaranteed. Any functional contact up here, especially distal incisal laterals, is kiss of death. You will get that crown back if you leave that in there. So what I'm going to try is increasing this plane here, this distolingual plane on the cuspid, with my plus tool, and see if I can't get guidance, make a little ridge down the middle, see if I can't get something that's going to eliminate some of these problems. And fill it in. I'm going to add a pretty decent ridge, okay? And I did get rid of this, but these things are still in the way. This probably wouldn't be destructive, but I kind of like to keep the laterals out of the protrusive function. So I tried adding a little more, and again, didn't want to get it too gnarly here. So then I looked in here and saw this area where, you know, maybe I can catch the tip of this cuspid, you know, a little bit protrusive, a little bit lateral, and share some of the function over a wider area, which is always nice. And we did that, but it turns out this is not the best I could do with a flat angle here, protrusive all the way to where these meet. That's where you have to stop. So, you know, now I'm really just going to bulge up the marginal ridges on the centrals and see if I can't create a scenario where we have decent guidance that eliminates anything on the laterals. I removed a little bit there and cut my occlusion, and then, you know, I'm good with that. Here's a little working, a little bit of protrusive, tiny. You know what? I feel pretty good about this. Okay, so, you know, when I see this, I'm going, okay, this is pretty well designed. I don't have anything of protrusion back here, taken over a diastema here. I wasn't able to get it. Never checked my thickness when I was doing this. You always want to do that. Make sure you have at least 5/10 back there, because I always leave the linguals monolithic. Okay, and since I take my time designing this, I never say yes to any of these questions ever. It's usually referencing a thinness near a margin, and we'll just end up bulking your crown and giving you contour you don't want, because it'll pick up on something like this, which is fine to be thin, and it'll bulk it out. Now, what do you do about this, right? This is kind of where we're going with the whole thing. You know, we know that on plastic it's non-physiologic. Non-physiologic geometry, tooth guidance is only, quadrants are even worse, okay? And they're worse because we have zero balancing side teeth. So the movements that you see in Virtual Articulator will not be seen by the technician, right? That's, like we said, it's exactly why a lot of grinding takes place at the bench. So if we look at how we deal with these first, just a couple quick modeling tips. These are mistakes that I see over and over and over again. So after you position your tooth roughly, you know, make sure that you roll it, usually lingually, in order to get the buccal cuss tips into the occluding fossa, and that these lingual cuss tips, if it's this lower tooth, into the opposing fossa. You know, just get the basic relationship of cusps to fossas. Okay, then always look at this. Look at where your developmental grooves are relative to where the ridges are on the opposing teeth, because these are meant to pass by each other in lateral, okay? So they should be there. So we want to take that groove and just grab it, with the little, this tool here, whatever it's called, the little magic wand or whatever it is, and then move that. And then look at this one, right? It should be back there, actually right there. So we're going to move this one back so that this ridge will actually go through there. And then go ahead and just kind of close my contact with this little peanut cusp. And that's what I should have. So I rarely find a library tooth that's exactly right for what I'm wanting to do ever. Just check these couple things, make sure your cusp-fossa relationships are good, and that your developmental groove and that you have opposing cusps have a gateway to move through in lateral. Okay, and again, once I've done this, next step, boom, go right here and check for that penetrating occlusion before I cut any occlusion, because I always lift this up, okay? And it's 20. I may go one more to eliminate that, but 200 microns is a lot. And again, optimize, I don't know, it will do things. See, like it'll move it from there to like there. And in this case, it picked it up, but it does things to the occlusion that I think are not right. 3Shape is the only one that I'm familiar with. So then the last thing I really want to talk about here is go ahead and establish, nice, broad, like the bottom of a bowl type centric contacts. And then, look and see, yep, we're on our cusp tips, things are good, we've got these, we got what we want, all the cusps represented. Then once we have this, find the depth of it, and that's where your groove goes. I mean, it's really just kind of use the occlusion to design your occlusal. Okay, and just do what you want. I mean, I'll do a little something. I'll cut to 0.01 always to keep just enough contact to see, smooth out the little things I did, and I'm ready to go. Okay, on the Virtual Articulator. But remember, this is a quadrant. So should we even use a Virtual Articulator? I mean, because right, and because this is what we have. So. My first idea was, well, hey, maybe I should just move this up to where these condyles match, right? Because it's going to use this machine to move this thing. And use zero guidance, right? Keep it flat, let things just move out, and the maximum bend I can get so they can slop all around side to side. And it was okay. Then I discovered the 3Shape generic articulator, which I had never seen before. And I like it because it lets me do things the other one doesn't. Firstly, though, if you have like a little quadrant on a small quad, put it right in the middle like this, okay? If you have a larger quad, I go in here, I tend to get better function, may move that one out, but anything bigger than this coming around the corner, I want to go ahead and put it in the right place as far as the placement goes. Then I want to move the articulator the wrong way and angle this backwards, all right, and then move it all the way up so that my business tooth is pretty much even with the condyle. And yeah, it looks totally wrong, but I'm telling you, it works. But it's also wrong to mount a quadrant on a full frame articulator. It doesn't work. But you can do this and save it, right, with that function, and then you'll get a lot closer every time that you do a case. But I wouldn't save it until I do this. I want maximum bend, but here's another bug. You can't type numbers in here. It's crazy. It messes all up. So I found that on the bend field, if you type 99, it'll go to 20, which is what you want. And on the condyle feed, if you hit the number 1, it'll go to 10, which is the lowest you can go on this articulator. It won't go to 0. So I'll typically uncheck the Guided by Designs box initially, run through one motion, and look to see, okay? I want to see this. I want to see all kinds of interference because this means I'm getting tooth guidance, all right? Why is that not have any marks on it? So I'll grab my articulator and look and see, yep, it was anterior open bite. So this shouldn't have any. This is good. I've certainly got all my balancing, and that's typically what you want. Not too much working, but this is good. And double check it. Then it's just the same old thing. We remove what we don't want. We turn this back on to Guided by Designs, and here's these existing balancing interferences. Is this a problem? No, remember, this is a quadrant, okay? If this was a full arch on an articulator, yes, we'd have to go increase guidance to fix that, okay? But not now. We actually want to see this, right? We get rid of our balancing, our working, blue, and our protrusive. Green and gray are the worst, okay? And again, it's just a process of going through with your sculpting tools, running the articulator, and getting rid of things that we don't want to have. All right, and again, through the working, if I have a small working, like I said, I don't sweat it. Okay, it's not a bad deal at all. Always turn on your depth colors to make sure you haven't gone too far. I like to have 1 millimeter on Emax, and 0.5 is where I'll set it, and I'll try to fix any of these little areas that I created while I was doing my work on the occlusal. All right, and then basically run it one last time. Don't worry about that, and I don't worry about these. You know, I really don't want to. I never, like I said, I never say yes to this question. I don't want it bulging that stuff out. I'm okay being a little thin. I mean, I've got some facial contours that I want to duplicate on a particular tooth. But when you talk about full arch on plastic, you want to do exactly the same thing. Center of the arch normally, but put it up there and even a little higher than this where you're, you know, kind of like you can go up in there a little bit. This might be a bit much. Play with this some and look on whatever articulator you use, which one gives you the same marks. I always watch it. But I did find one exception on just really flat, like what we call a cow chewer. This is one exception, okay, that I kind of keep it flat. But again, move the angles around a little bit and kind of play with front to back. But you're always going to be somewhere in this area and either flat or slightly tilted backwards to make this work right. So you got to do it wrong to make it work right because the articulator is wrong. So anyway, on this one, again, it's full arch, but it was mounted on plastic. I look to see what kind of marks I get initially when I run it through, and what about all this? I got nothing. Is that right? So you see something, verify it. Look at your actual mounting and see. Are these missing in lateral? In this case, they were. And then we, you know, basically adjust the occlusion. These, I'm showing you these because these are crowns that came right out. These happen to be Emax, but exactly the same result on Zirconia. That, you know, when I run through with my different colored tapes, I'm getting all centric, no excursive interferences from these crowns that we basically run through Articulator with this approach, and it's just been phenomenal. I would say our grinding on many crowns is 0 at the bench, and we're finding we can Sinter, glaze, and go with a lot of our work, probably 70%. That we really don't even have to, well, we always touch a proximal contact because I do make those a touch heavy. That's just me, you know, and then do them. So, but talking about, what about a case like this, full arch, but it's on a plastic articulator? Do you do this, right? I mean, it's on a plastic articulator, it's on an Orbix, but the answer is no. Okay, if you're doing an anterior case, you've got to get anterior guidance that's going to work in the patient's mouth. You've got to adjust it on here, you know, and just kind of believe it's going to be pretty good. But also, we all know what it's like trying to get accurate protrusion on a plastic articulator. So I'll design them here. I won't really pay much attention to it when I get to the bench, and I'm adjusting that. All right, so if we look at 3Shape, you know, they give us all these articulators, right? And you can pick whatever pretty picture you like or whichever one you use. What they don't give us is this. I really wish they would give you a, you know, plastic option that puts the condyle here, right? That lets it move like it's supposed to, so we don't have to do all this mess in order to, you know, fool the system to work for what we do most of the time, which is quadrant models on little plastic, you know, move around articulators. So now we have everything is properly designed and milled, right? We've got everything, you know, we've got a system, you know, now what, right? Now what do we do? Well, guys, that is going to be next time when we talk about, you know, coloring, working with Zirconia, how to get different surface texture. Oh, and I threw this in because I just got this picture yesterday from a doc, and this happens to be a crown, the one I just showed you, that has no stain, no glaze. It was polished with flour pumice. And is it perfect? No. I mean, do I wish I'd used a little lower value in size? Well, yeah, but hey, I mean, not bad for freaking Zirconia at 1140 megapascals. This is the Pro. It's the new hybrid Zirconia, which I got to tell you, I'm loving. I think its vitality and its value is damn near perfect. So that's going to do us for today. Again, I hope you guys will, you know, come back and see the conclusion of this when we see how we take what we did and get it exactly perfect, centered, and out the door, which hopefully is the point. Thank you very much.
Al, thank you very much. Great program. Can't wait for the second part. For those of you who are still with us, and it's a pretty big group, shockingly no questions, but I guess that lets Al off the hook.
It was just that good.
It means that you covered every possible angle.
I guess. Okay.
Anyway, before you go, just a reminder that if you are a CDT or a recognized graduate, this will be worth an hour toward your recertification. You will get notification, or the email you signed in on will get a notification within 1 to 2 days as to how you will receive the credit. Very easy. And the second thing is the webinar has been recorded, and so within 24 to 48 hours or so, it will be up on the Whitmix website. So you're able to rewatch that, and credit can be given for any future viewing. Questions
it went pretty fast.
came in. Well, actually, they're not questions. Al, check this out. We have one comment. The best webinar I've ever been. Thank you so much.
Hey, hey guys, I'm serious. This really does work. And this picture on the screen, if you're still here, these are all crowns straight out of the centering furnace that haven't been touched. I mean, which that's what I want. Man, I don't like this, make them a shade lighter and stain them. I don't like stain. It comes off, it kills vitality. If we can get away from that and then not be doing all that grinding and sparking at the bench, that's a cool thing. So I hope you come next time.
The other comments were the same, Al. One was laugh out loud, questions are too much, but the presentation was awesome. Thanks, Al.
You're welcome.
Another one was, love this, thank you so much. Another one was, it was amazing. That is why nobody asks any questions. And then lastly, really nice work. You're a rock star, Al. Thanks again.
Well, thank you. Hey, I really appreciate that. No, seriously, you really never know, because it's a ton of work and it's really nice to get good feedback. Thank you. I appreciate it.
Thank you, Alan. Thank you all for attending. And don't forget, part 2 next Tuesday, April 9th at 11 o'clock Eastern Standard Time. Hope to see you all there. Take care.